Have you ever looked at a vast, icy landscape, like Greenland or Antarctica, and wondered what lies beneath? For most of human history, these colossal ice sheets have been frozen in their secrets, locked away under kilometers of solid ice. But what if I told you that beneath that impenetrable facade lies a treasure trove of resources, minerals that could power our future and reshape our world? Today, we're journeying to the frontiers of human ingenuity, deep beneath the ice, to explore the incredible world of subglacial mining. Imagine a mine, not carved into a mountainside, but melted directly into a glacier. This isn't science fiction. It's the cutting edge of engineering. The challenges are immense. We're talking about temperatures that can freeze machinery solid in minutes, ice that is constantly moving and shifting, and the crushing pressure of millions of tons of ice overhead. How do you even begin to operate in such an extreme environment? The first step is figuring out what's actually down there. Scientists and engineers use a combination of ground-penetrating radar, seismic surveys, and sophisticated drilling techniques. They send energy waves deep into the ice, and by analyzing how those waves bounce back, they can create a detailed 3D map of the bedrock below. It's like giving the Earth an ultrasound to find veins of gold, copper, diamonds, or rare earth elements. Finding a promising deposit is just the beginning. The real challenge is getting to it. One of the most groundbreaking concepts is the use of thermal drills. Instead of traditional mechanical drilling, which would struggle against the sheer cold and abrasive nature of ice, these drills use heat. A heated drill head melts its way down through the glacier, creating a stable, water-lined shaft. This shaft, or borehole, can be hundreds or even thousands of meters deep. Once the shaft reaches the bedrock, it can be expanded to create tunnels and caverns for the mining operation itself. Think about the engineering marvel this represents. You're essentially creating a self-contained habitat and industrial site, a bubble of warmth and activity, completely encased in ice. The water from the melted ice isn't a waste product either. It can be used for the mining process, for generating power, and even as a source of drinking water for the crew. It's a closed-loop system, a testament to sustainable design in the harshest place on Earth. So, what are they mining for? The potential is staggering. The landmass is hidden beneath these ice sheets, particularly in places like Greenland and Antarctica, are geologically ancient and largely unexplored. They are believed to hold vast deposits of iron, copper, nickel, gold, and platinum. But perhaps most importantly, they could be a critical source of rare earth elements there. Minerals essential for our modern technology, from smartphones and electric vehicle batteries to wind turbines and defense systems. The geopolitical implications are enormous. As global demand for these resources skyrockets, nations are looking to secure their own supply chains. The Arctic and Antarctic regions are becoming new arenas for strategic competition. Countries are investing heavily in polar research and infrastructure, not just for science, but to stake their claim on the resources that lie beneath the ice. This isn't just about geology. It's about the future of global power and economics. Of course, pioneering such a new frontier comes with immense responsibility. Subglacial mining has to be done with extreme care for the environment. The ecosystems in these polar regions are incredibly fragile. A single spill or misstep could have catastrophic and long-lasting consequences. That's why the technology being developed isn't just about extraction, it's about containment. Mining operations are being designed as completely sealed systems. All waste materials, water, and even air are contained and processed within the subglacial facility, preventing any contamination of the pristine ice sheet above or the delicate marine environment below. Furthermore, scientists are closely monitoring the potential impact on the glaciers themselves. Could the heat from a mining operation accelerate melting? Could it destabilize the ice sheet? These are critical questions that researchers are working tirelessly to answer. The goal is to develop methods that allow for resource extraction with a near-zero environmental footprint. It is a delicate balancing act between meeting humanity's needs and preserving our planet's last true wildernesses. Let's talk about the people who make this possible. The miners, engineers, and scientists working in these subglacial outposts are a special breed. They live and work for months at a time in complete isolation, under conditions that would test the limits of human endurance. Their workplaces are some of the most remote and dangerous on the planet. They rely on cutting-edge robotics and automation to perform many of the most hazardous tasks, operating heavy machinery from the safety of a control room deep within the ice. This fusion of human grit and robotic precision is what makes subglacial mining a reality. Drones and autonomous vehicles can survey tunnels, transport materials, and perform maintenance, minimizing the risks to human personnel. It's a vision of the future of industry, where technology doesn't just improve efficiency, but fundamentally protects human life in extreme settings. As we look ahead, the potential of subglacial mining is only just beginning to be understood. We are standing on the precipice of a new age of exploration and resource discovery. The technologies being honed beneath the ice could one day be applied to even more ambitious projects, like mining on other planets or asteroids. The lessons we learn about building sustainable, self-sufficient habitats in extreme environments on Earth are the very same lessons we need to become a multi-planetary species. The journey beneath the ice is more than just a quest for minerals. It's a story of human ambition, technological innovation, and our evolving relationship with our planet. It forces us to ask big questions about our future, our needs, and our responsibilities. As we melt our way into this hidden world, we are not just uncovering rocks and metals. We are uncovering new possibilities for the future of civilization itself. What do you think? Is subglacial mining a necessary step for our technological progress? Or is it a risk we shouldn't take? Let me know your thoughts in the comments below. It's a complex issue with no easy answers, and I'd love to hear your perspective. Thanks for joining me on this deep dive into one of the world's most extreme industries. If you found this journey as fascinating as I did, make sure to hit that like button and subscribe for more explorations into the cutting edge of science and technology. See you in the next one.